For over 100 years, one rule held across the entire universe. A limit on how fast anything could feed, how fast anything could grow. Every black hole obeyed it. The small ones, the giants, every single one. Then we looked into the first light of the cosmos, 12 billion years into the past. Before the Earth, before the Sun, before us, and found something feeding at 40 times beyond the line. Not a giant. That is the terrifying part. Something small, doing what nothing its size should ever be able to do. It has been feeding since before our world had a name, and we almost never found it at all. Its name is LID 568, a small black hole, feeding like something it has no right to be. So what could possibly let it break a law the universe has kept for 100 years? In 1921, a man named Arthur Eddington found a ceiling written into the universe. Not a law anyone passed, a consequence, a line drawn by physics itself. It works like this. When a black hole feeds, the matter falling in does not go quietly. It compresses, it heats, it blazes. And that outpouring of radiation pushes outward against the very gravity pulling the matter in. Feed too greedily, and the glare of your own meal blows the rest of it away. There is a point where the pushing and the pulling balance perfectly. A speed limit on hunger. Beyond it, the feast is supposed to end itself. For 100 years it always did. Every black hole we ever found, the small ones, the giants, the quasars burning brighter than 1 trillion stars, every single one stayed beneath the line. The universe seemed to police its own appetite. It did not matter how massive the black hole was. It did not matter how much gas surrounded it, or how violent the galaxy it lived in. The math was the same everywhere. The brighter the feast burned, the harder its own light shoved back. A leash the cosmos never once let slip. There was no known exception, not one. For a century, the rule held. And then we looked into the deep past and found something that had never heard of it. To look far into space is to look far into time. Light is fast, but not infinite. 300,000 kilometers each second, and not one more. The light from something 10 billion light years away left it 10 billion years ago. To stare into the deep universe is to stare into its childhood. And its childhood is haunted. Out at the very edge of what we can see, in light that has been traveling for more than 13 billion years, there are black holes that already existed when the universe was barely 1 billion years old. And some of them already weighed as much as 1 billion suns. 1 billion suns worth of darkness, assembled in less time than it should take to assemble a fraction of it. By every rule we know, by the ceiling Eddington drew, that is not possible. A black hole growing as fast as physics permits, from the moment the first stars died, could not become that vast that quickly. The arithmetic of creation does not close. Think about what it would take. To gather 1 billion suns of mass, a black hole needs fuel beyond imagining, and time to swallow all of it. The early universe was generous with the fuel. It was miserly with the time, and the equations, run honestly, always came up short, by hundreds of millions of years. Astronomers gave the unease a quiet, careful name: the early universe monster problem. They built models. They stretched the timelines. They searched for a way the cosmos could have grown its giants faster. Nothing quite worked. The monsters were too big, too early, as if the universe had been building something in the dark before it was supposed to know how. And then, a telescope 1 million miles from Earth caught one of them. Not finished, not resting, but in the act of feeding. LID 568. For years it hid in a catalogue of faint X-ray sources, in a galaxy so wrapped in dust that ordinary light could not escape it. Hubble looked and saw nothing. To almost every eye ever built, it simply was not there. But in X-rays, it screamed. A team led by the astronomer Hae-Won Soo of the US National Science Foundation's Noy Lab turned the James Webb Space Telescope toward that scream and used an instrument sensitive enough to read the faint infrared glow bleeding through the dust. They could not even be sure of the exact point it sat. The X-rays marked the region, not the spot. So they let Webb's spectrograph read a separate sliver of light across the entire field at once, and waited to see what the dust had been keeping from us. What they pulled out of the dark, they published in Nature Astronomy. When they finally worked out how fiercely it was burning, the number landed so far past possible that the first instinct was to distrust it. To recheck the instruments, to recheck the math, to assume someone, somewhere, had made a mistake. The instruments were fine. The math held. The thing was simply doing what could not be done. And here is where the fear sharpens into something specific. Because LID 568 is not one of the giants. It is small. A black hole of only a few million suns. A lightweight by cosmic standards. The kind that is supposed to feed gently, grow slowly, mind the line. And it was feeding at 40 times the limit, not twice, not 10 times, 40. A small thing, eating like something 40 times beyond what the universe permits anything to eat. The radiation should have blown its meal into the void. The feast should have strangled itself, the way 100 years of physics promised it would. It did not. The gas kept falling, all of it, into a mouth that was never supposed to be able to open that wide. Numbers go numb at this scale. 40 times. It sounds like nothing without something to hold it against. So hold it against time. The ceiling Eddington drew is not only a limit on brightness, it is a limit on growth, the fastest a black hole can fatten before its own light starves it. Under that limit, a black hole grows with the patience of geology. Doubling takes spans long enough for galaxies to wheel and rearrange. Now tear the patience away. Run the clock 40 times faster. At 40 times the limit, a small seed does not stay small. A black hole of a few million suns could swell toward a billion, toward true monstrousness inside the narrow first act of the universe. Fast enough to become exactly the kind of thing astronomers could not explain. Run the early universe forward under the old rules, and the giants simply never arrive. The seed is too small. The clock is too short. The arithmetic strands them in the cradle, half-grown, at the very moment the real cosmos shows them already vast, already burning, already monstrous. Unless something had been feeding them, like this. And that is the moment the unease turns cold, because LID 568 is not just a record being broken, it is a demonstration. Proof, caught in the act, that the early universe possessed a way to grow its monsters at impossible speed. We had been asking how the giants got so big, so fast, and here was one, showing us. We just don't fully understand what we were looking at. Be clear about one thing. LID 568 did not tear up the laws of physics. The ceiling describes a calm universe, smooth, steady, balanced feeding. But the early cosmos was anything but calm. Under violent enough conditions, matter can pour in along narrow channels while the radiation escapes elsewhere, letting a black hole gorge far past the line. For a while is the whole horror of it. When Webb's spectrograph mapped the gas around LID 568, it found great outflows, material being driven outward at tremendous speed. From their size and violence, the team concluded that much of this black hole's mass may have been built in a single, rapid burst of feeding. One catastrophic episode of hunger, not slow growth across the ages. A thing caught mid-swallow. Those outflows are the fingerprint. Gas does not simply vanish into a black hole. When the disk takes in more than it can hold, some of that matter is hurled back out, fast and scorching, in great driven winds. Webb did not only measure the feeding, it measured the recoil of it. The violence of a mouth straining against its own limit, and not stopping. This is the leading explanation, and it is a serious one. Not because it tames the mystery, but because it points somewhere darker. If short, savage, super Eddington bursts are real, then this may be the mechanism. The thing that built the first monsters faster than the universe should have been able to build anything. We can see what it did. We can guess at how. But we cannot yet reproduce those conditions in any equation, any simulation, any laboratory that has ever existed. The full machinery of it lies just past the edge of what we can model. The universe did this, and it did not leave us the instructions. LID 568 lived just 1.5 billion years after the Big Bang, when the universe was barely a tenth of its present age. That place is gone now. It was denser, wilder, drowning in raw gas in quantities the cosmos has long since burned, scattered, or buried inside stars. The thin, quiet universe we live in could not easily build such a thing today. The fuel is gone. The conditions have passed. That is what unsettles the people who study it. The early universe was not a smaller, younger version of our own. It was another country entirely. Hotter, denser, drowning in the raw material of creation, running processes that have no equal in the calm sky we look up at tonight. But back then, a small black hole at the heart of a gas-choked, dust-shrouded galaxy had everything it needed. A bottomless supply. And the chaos to pour it inward faster than the light of the feast could push it away. There was no Milky Way yet, no sun, no Earth. The atoms that would one day become every living thing on this planet were still drifting as cold, formless gas. And already, something was eating like a god. When we catalogue the giant black holes of those first galaxies, the same wrongness keeps returning. Too big, too early, a pattern that refuses to dissolve. LID 568 suggests the pattern has a source we can finally glimpse. Not a freak, not an exception, the clearest face yet of an entire generation of monsters born in conditions the universe will never offer again. Remember why we almost missed it? It was buried. The same dust and gas that fed LID 568 also hid it. Blazing in X-rays, invisible in ordinary light. Every telescope before Webb swept past it and saw nothing at all. And that is the question that should keep you awake. If a black hole eating at 40 times the limit could sit in plain view of our instruments and stay hidden behind a veil of dust until the right eye looked the right way, how many others are still hidden? The early universe was full of dust, full of gas, full of exactly the dark, opaque cradles that let things like this grow and stay unseen. Every survey built before we could pierce that dust carried a blind spot, woven in from the start. And the dust does not hide at random. It hides, above all, the ones feeding hardest, the ones swaddled in the very gas they are devouring. The most monstrous appetites are the easiest to lose in the dark, which raises a thought colder than any single discovery. Our map of the early universe may be a map of the quiet ones, the tame ones, the visible minority, while the true feeders sat just behind the veil, uncounted the whole time. LID 568 is one we happened to catch. It is almost certainly not alone. Somewhere in the deep field images that pour back from Webb night after night, among the faint smudges we glance over without a second thought, there may be a whole hidden population, feeding, growing, anchoring galaxies whose centers we have never truly seen. We named one of the monsters. The rest are still in the dark. Return to the thing itself. A few million suns of mass, crushed into a region absurdly small by the measure of the heavens. Its event horizon, the boundary past which nothing, not even light, returns. Wudhudunset would nest inside the orbits of the inner planets. A speck set against the galaxy around it. A pinpoint carrying the weight of millions of stars. That is what makes a black hole more than simply a very heavy thing. It is not the mass, it is the concentration. The same matter that, spread across a star, would make warmth and light, and a steady fire. Folded down until space-time itself can no longer hold its shape. And inside that boundary, direction loses its meaning. Forward stops being a place and becomes a moment. Time, in there, runs one way only, inward, toward the center. There is no future that does not end at the singularity. No path that turns back out. Cross that line, and the universe offers you exactly one destination, and exactly one direction in which to reach it. The center. Always the center. And whatever waits there, we have no words for. Now picture that speck, feeding, the horizon swelling, the gravity deepening. More matter screaming inward, blazing, and still falling against everything. The boundary growing, the pull tightening. The space around it bending harder with every passing year. It was not merely eating matter. It was bending the shape of everything near it. And it had 12 billion years to keep going. The light that revealed LID 568 left it 12.3 billion years ago. When it set out, there was no Milky Way, no sun, no Earth. The story of this planet had not begun. Its atoms were still loose in the dark. That light, carrying the X-ray and infrared signature of a small black hole feeding at 40 times the limit, crossed an expanding universe for 12 billion years. It threaded the voids between clusters. It slipped through structures that were born and grew old and died while it traveled. And it arrived at last at a machine built by a species that did not exist when the light departed. What it told us, when we finally read it, was this: the universe knew how to grow monsters faster than we believed it could. Not at the trembling edge of measurement, plainly, at 40 times the line. It was building things, in the dark of its first morning, by means we are only beginning to understand. And consider the vertigo of what we are actually watching. This light is a recording 12 billion years old, the creature's infancy. But the creature in the recording is no longer a child. It grew up off camera, across an abyss of time, in a dark we cannot reach. We will never see a single frame of what it became. We have only the cry it made as an infant. And then, the world barely looked up. It was published. It was reported. Astronomers spoke of it carefully, in the measured voice of people who know the cost of an extraordinary claim. And then the world moved on. That is how it goes with findings like this. They do not close a question, they widen it. There is no triumph, no neat ending. Only a discovery, and then the long, patient labor of asking what it means. But LID 568 is still there. Or rather, what it became is still there. Larger now, older. The product of a process born in conditions we cannot recreate, running on machinery we cannot fully model, in a universe that no longer exists in the form that made it. Webb keeps watching, and with every image, more of that first morning comes into view, and more black holes that are too big, too early, too fast. Each one asks the same thing. What were the rules back then? And why do they look so different now? There is no clean answer. And this is where the story stops moving forward and begins to fall. This is the part that does not resolve. Science moves towards certainty. Each answer sharpens the next question. The universe gives itself up, slowly, to anyone patient enough to watch. LID 568 does not give itself up. Not because the physics failed, the ceiling still stands, but because the thing sits at the very rim of what our models can hold. We can describe what it did. We can name a candidate for how. What we cannot do is reach all the way to the bottom of it. There is a particular dread in that kind of not knowing. It is not the comfortable gap of a question simply waiting to be answered. It is the colder suspicion that the map of the early universe was drawn from a gentler country than the one that actually existed, and that the true territory holds regions the map makers never set foot in. Something was at work in the dark of the first billion years. It left behind objects we can measure, but not yet explain. And new eyes are coming. Sharper telescopes, tuned to cut deeper into the dust, to read fainter light, to count the monsters we have been missing. Every honest astronomer knows what that promises, that the number we have now is a floor, never a ceiling. That the infant universe is almost certainly stranger and far more crowded than the map we have dared to draw of it. What that something was is still unknown, which brings us back to where this began. In 1921, Arthur Eddington wrote a limit into the universe. He derived it from first principles, from the eternal contest between gravity pulling in and radiation pushing out. For 100 years, the cosmos honored it. Every black hole, every galaxy, every instrument we ever raised to the sky agreed. Then a telescope a million miles from home turned toward a dust-wrapped smudge of ancient light and found a small thing feeding at 40 times the line, caught mid-feast, doing what it had no business sustaining and sustaining it anyway. The rule did not fall, but our sense of what the early universe was capable of did. Because if a lightweight could eat like this, fast enough, fierce enough, to swell into a giant in the blink of cosmic time, then the monsters we could never explain may have been forged exactly this way. All along, in the dust and gas of an infant cosmos, by a hand we still cannot fully see. And that is the thought that lingers. Not that a single black hole bent a single rule, but that the universe may have owned a method for making giants from the very beginning. That it ran that method in the dark, at the dawn of everything, and never told us how. A method we are now trying to rebuild from one faint cry of ancient light and from the silence around everything we failed to catch. What the full mechanism was, how many others did the same. What LID 568 grew into across 12 billion unwatched years. Where it sits, this very second. These questions are open. They will stay open for years, perhaps generations, as we build new eyes and learn new ways to see through the dark. And somewhere out there, in a direction our instruments can only roughly point, at a distance no journey could ever cross, the thing LID 568 became is real and present and now. 12 billion years of feeding, of a horizon swelling and space-time folding around something that began already doing the impossible. We do not know what it became. We do not know how large. We do not know exactly where. What we know is only this: the LID 568 we saw was its infant form. And even that stayed hidden in the dark until the right eye, at the right moment, looked the right way. It is out there right now, not a memory, not old light crossing the void. A present thing at the center of a galaxy. In a universe it has had 12 billion years to grow into. And somewhere in the dark between what we can see and what we cannot, it is still feeding. That question does not leave when the screen goes black. If the infant universe could grow a monster like this, by a mechanism we still cannot fully explain, how many more are out there, sitting at the centers of galaxies we drift past every night, without ever knowing what holds them together? Leave your answer below. And if this is the kind of question that follows you into the dark, that feeling is the point. Hit like. It helps more people find their way to the edge of what physics can explain. There is more out here. We have only just begun to look.